We are live. Good. Right. So this goes out to the world. Don't swear.
This computer has been today.
Really? Only today?
It's very slow.
Please come in. Good morning, ladies and jelly beans. No stress, no stress. Could you please do that?
No, I can't because it's not saved otherwise. I mean, I still have 2 minutes. I mean, you have 7 minutes. So.
Okay. Sorry?
Can I do it while you're waiting to get on the PC?
Well, don't worry. We don't start before 5 past.
No, that's fine. I'll wait. I want to disrupt this little bit of wait.
Oh, don't worry about it.
I'm done.
Thank you.
And I think I'm on time because we won't start before some time.
For heaven's sake. We're on business. All yours.
I'm aware that there has been some attendance monitoring issues and concerns from Stage 1 students about signing the form, about how long it's taken to sign the form. So I'm having a look into that and to see how we can do it better. So what I'm trialling today, and I'm afraid you're my guinea pigs, bottom, there should be a section called Attendance Test. Can you see it? Just click in if you're here. So it's a choice thing, so you just click in if you're here, and that will register your attendance. Has everyone found it? Yeah? Has anybody not found it? So you can scroll back on your Moodle. So scroll right down the bottom. After all the pictures. Have you got it? You've got it? Yeah? You've got it as well? Is there anybody who can't find it? Perfect. I'm going to analyse how that works, and if that works, then we might look at going online for some of your attendance monitoring.
So, of course, you can do that from home as well.
No, you can't.
I thought you can. As long as you can access Moodle, you can do it.
You
Look,
can, but the
look,
good is
look, they are clever enough to figure that out. I don't have to tell them that.
Will only be open for the 50 minutes of your lecture.
Okay, so you know it's only open.
Bane of my life.
At your service. God give me strength. I mean, how long would it have taken you to figure out that you can do the attendance monitoring from home? Huh? Are you stupid or are you stupid? I tell you something. This country sometimes. Right, welcome to sort of a little bit of maths revision, whether you need it or not. Thank you also for a lot of people who have done this diagnostic test. It was really, really interesting for me to see that there is a huge spectrum of skills. And so some people apparently didn't have any problems with the questions. And for other people, let me phrase it this way, certainly there are more learning opportunities, right? And so what I'm going to pick out is just a few things where I think that is something that, without being totally confident in this procedure, it would be difficult to survive the degree. Because, let's face it, biosciences is a science subject, and you are dealing with numbers. It's important. I mean, if you don't like numbers, I would have suggested to you that you do film studies. But then the problem is, I sat in on a lecture, they discuss aspect ratios, 14:3 and 16:9 and things like that. So you've got numbers there as well, so bugger it. Right, just a few things that I would like to discuss with you. And we start from really simple to getting a little bit more oomph, if you know what I mean. So here is, I think, was one of the first questions where you just simply calculate A in this case, and there were a few very interesting things that people did. The important thing that I want to harp on about here is that you have the order of operations. So on the lowest level, you have addition and subtraction. So you've got plus and minus. On the next higher level, you have multiplication and division. And then you have exponents and roots. So I write this as power, that's exponent, and roots. And there is a very clear hierarchy in these operations. So if you if you want to sort of override this hierarchy, you can group things with brackets. So I just indicate it like that with brackets. If you have more than one override, you can, for simplicity, you can use different kinds of brackets. So, for example, curly brackets or square brackets. That makes it easier for you to see actually where things belong together. So here in this example, a equals 10 minus 1.5 times 2 plus 3. You basically have the first two levels here. And the way you need to read that is calculate 2 plus 3, because there is a bracket. Calculate this first. The bracket has sort of priority. So 2 plus 3, obviously, that is 5. And then you have 10 minus 1.5 times 5. Yeah? And here you have the hierarchy. You must do the multiplication first before you do anything else. So 1.5 times 5, according to my fingers, that gives me 7.5. So you need to do that first, 7.5. And then you have 10 minus 7.5. This gives you 2.5. Right? I know that some people have brutally ignored, and where's my pen gone? Oh, wow, cool. I've got something black here. No? That's certainly interesting. I just erase it. Ha, how cool. Let's just leave it here, our hierarchy. I know that some people have done something really weird. They have said, okay, I need to do 10 minus 1.5. So that is 8.5 times 2 gives me 17 plus 3 gives me 20. And because I'm a really mean bastard, I put that in as a potential answer, right? There were quite a number of people who fell for it. Okay? So, you know how you do it. Brackets first, multiplication has priority over plus and minus, multiplication and division. Makes sense, yeah? Bodmas. I think that was the thing in school. This one here, oh, I love that. The two things. It makes your eyes go funny. Right, let's do that together, okay? So we have 2 times 2 plus 2 plus 2 times 2 times 2 times 2 minus 2 times 2. And the easiest way of dealing with that is, remember, you have to do multiplications before you do any addition or subtraction. So, the way I used to do that is I circle all the multiplications. And do the multiplications first. So 2 times 2 gives 4. Plus 2 plus, now I have this larger bit. 2 times 2 gives 4 times 2 is 8 times 2 is 16. Minus 2 times 2, that's 4 again. So I have 4 plus 2, that gives 6, plus 16, that gives 22, minus 4 gives 18. Yeah? Does that make sense? The nice thing is that sometimes people do it in cold blood. They go like, hey, 2 times 2, that's 4, plus 2, that's 6, plus 2, that's 8, times 2 is 16, times 2 is 32, times 2 is 72, minus 2 is 70, times 2 is 140. Must have some lost somewhere, because that probably can't do that in my head. But that's not the way how you can do it. Yeah, there is a strict hierarchy, and that's really, really important. Really bizarre where this thing went. Let me just simply. Where does that come from? Why is it black? This is totally bizarre. Okay. Is it still black? Nah, solved the problem. Right. Then there was another problem, and I think that threw people. And I was so glad to see that. It was 3x to the power of 3 bracket 2. Yeah? Now, here we have the issue of a multiplication, a bracket, and something to the power. First of all, let's just quickly discuss how do we deal if we have the power of a power. I got the power. So what if we have x to the power of 3 to the power of 2? How do we deal with exponents? So if we have an exponent like this 3 here, to the power of another exponent, we multiply the exponents. So here we would get x to the power of 3 times 2. And I put a bracket around that just to indicate that we have to do that first. Yeah? Make sense? So that gives us x to the power of 6, if I'm correct. Okay? Happy with that? Now, we can write this here also as 3 to the power of 2 times x 3 to the power of 2. And that is where a lot of people went wrong, because they just did not take the 3 to the power of 2. But what this actually says is, take this, what's in this bracket here, which I completely destroyed now, take this, calculate this first, and then take everything to the power of 2. Right? So therefore, it means we also have to include the 3 in the power of 2. And of course, as you can see, we have 3 to the power of 2, which is 3 times 3. And x to the power of 6. Are you happy with that? Yeah? So these are the rules of exponents. And we will deal with, usually we deal with exponents all the time. So for example, 4 times 10 to the power of 2 times 2 times 10 to the power of 3. So how do we deal with that? Now the good thing is we only have a multiplication in here, so we don't have to be overly concerned about the order. There is no multiplication, there is no subtraction or addition in it. It's just multiplication and then the powers. So in a way, what we can do is we just simply can do 4 times 2 times 10 to the power of 2 times 10 to the power of 3. And if we multiply two terms that have the same base, and the base is this one here, this 10, so they have the same base, what we can do is we can combine them if there is a multiplication in it, and we can say it is the same base, 10, to, and this time it is the addition, 2 plus 3. Right? So when we are dealing with exponents, the multiplication becomes the addition of the exponents, to the power becomes the multiplication of the exponents. Sounds complicated, but it isn't. So here we have 8 times 10 to the power of 5. That make sense? What happens if we've got a negative exponent? How are we going to deal with 2 times 10 to the minus 3 times 2 times 10 to the power of 4? again, we do exactly as it says on the tin. We just simply take the two 2's, 2 times 2. Well, it's pretty simple and straightforward. Times 10 to the minus 3 times 10 to the 4. And for this, we can write, it's the same base, it's 10. 10 to the power of minus 3 plus 4. Again, I don't need a calculator for that. That's the same as 4 minus 3 equals 10 to the power of 1. So here we've got 2 times 2, which is 4, times 10 to the power of 1. What is 4 times 10 to the power of 1? Loud? 40. Yeah. Equals 40. What is 10 to the power of 0?
1.
Are you sure? Yeah? 100% sure? You're absolutely right. Is 1. 10 to the power of 0 is 1. What is 2 to the power of 0? Sorry? It's 1. So 10 to the power of 0 is 1, and that's the same as 2 to the power of 0. So 10 is the same as 2. I'm just messing with your brain. Of course it's not the same. 10 is not 2, yeah? But anything to the power of 0 is always 1. And anything to the power of 1 is always the anything. So 2 to the power of 1 is 2. 3.5 to the power of 1 is 3.5. Okay? Right. If we have, let's say, 2 to the power of 2 times 10 to the power of minus 1, we can also write this in a slightly different way. And the way I think about that is just simply think that this minus here well, let's do it. Let's make it easier. Let's get rid of the 2. Let's do a 1. This minus is just the leftover of a fraction line. That means we can write this as 1 times 10 to the power of 1. You see this minus here? That's now a large minus. And a negative exponent is actually a fraction that we are dealing with. So, I think one of the questions was simplify the expression 2 times 10 to the power of 4 times 3 times 10 to the power of 2 times 1.5 times 10 to the power of, oh no, divided by 1.5 times 10 to the power of minus 3. Hey, let's have a little bit of fun. Let's live a little. Let's simplify that. Now, the numerator is easy. We just do this part here. Two times 10 to the 4 times 3 times 10 to the 2. That we can write that as 2 times 3 times 10 to the power of, what do I have to write? Y6? You are absolutely right. 4 plus 2. We have the 4, we have a multiplication, and we have a 2. So the multiplication turns into a plus when we deal with exponents. So that gives us 6 times 10 to the power of 6. And, I'll write it down here, 6 times 10 to the power of 6 divided by 1.5 times 10 to the minus 3. Now, let's see what we can do with that. Six divided by 1.5, that's straightforward, that's 4. Yeah? Right? But now the tricky bit comes. 10 to the power of 6, that's straightforward. But what are we going to do with this 10 to the minus 3, which is in the denominator? Now again, the rule is very simple. Remember, we have a minus, that's the large fraction line. So we can write this one here, can write this as 10 times minus times minus 3. So let me just simply illustrate which one is which. The fraction line, the pink one, is the first minus, and the rest one is the minus 3. Now, of course, we have to calculate what is minus times minus 3. That's plus 3. That gives us 10 to the power of 3. Now we have 4 times 10 to the 6 times 10 to the 3. And again, that's easy, because we just simply add the exponents. 4 times 10 to the 6 plus 3. And that gives us 4 times 10 to the 9. Okay? So these are the rules of exponents. Does it make sense to you? You just need a little bit of practice. Where do you find practice? Well, I've got on my wonderful website that I'm going to advertise to you lots of practice questions. Don't know whether I have put down some exponent questions. But if in doubt, if your maths is a bit shaky, I would suggest a number of resources. One is just simply get a good GCSE maths book. Just go into the bookshop and say, I want to buy that for my little brother. Right? You don't have to admit that it's for you, although there's no shame in it. Right? My little brother needs it, and I do tutoring with my little brother, and I need to know. The other thing is, you all are aware of Khan Academy? Yeah? Anyone here who doesn't know what Khan Academy is? Hands up. Fantastic. That guy, Sal Khan, he is my hero. Has loads and loads of tutorials. One other thing that I want to do with you, and I know I have practice questions on my website for that, is rearranging an equation. So if you've got, for example, x plus 7 equals 21. It's a really easy thing to do, but I use that to show you the formal mechanism for that, how you deal with that. What we want to find out is x, obviously, right? That's the whole point. So what we want is, eventually we want to have something where it says x equals and that's obviously what we need to calculate. So what we need to do in this case is, everything with x is on one side. Everything that is not x will go to the other side. Right? So, here we have a mixture of x and a number. Clearly, we want x on that side, so x is all right, but we want to get rid of the 7. And what we can do, and we will do that quite frequently, what we can do is, we note that we have an addition here. We have a plus sign. And in order to get rid of a plus something, what we do is we do the inverse mathematical operation. So inverse operation. The inverse operation of addition is subtraction. The inverse operation, so I write that down, inverse operation, addition, subtraction. Inverse operation of multiplication is division. Inverse operation of to the power that's getting interesting. It's the inverse operation of to the power. Root? Right. The inverse operation to the power is something called logarithm. And we will discuss that next time. We will discuss that when we talk about pH. So for the time being, let's just simply look at this one here. So the inverse operation of addition is subtraction. And I indicate that just simply by doing that. -7. So what does that mean? We have x plus 7 minus 7, that's the inverse operation, equals 21 minus 7. And here the really, really important thing is, what I do to one side of the equation, I must do to the other side of the equation. There's no other way. Right? There's no other way. It has to be done to both sides. It's a little bit like if you have twins. You can't buy one twin an Xbox for Christmas and the other one gets an orange. You have a riot at your hands, I can tell you that. Yeah? It's absolutely impossible. You have to buy, well, you can either go for 2 Xboxes or 2 oranges. Whichever way, works for you, but you can't treat them differently. What do you get with that? Well, you have plus 7, minus 7. What gives that? Of course, that gives 0. And on the right-hand side, you have 21 minus 7. So you have x plus 0, and conventionally we don't write that, the 0, if it is a plus. So we just simply write x equals 14. And what you see, we have all the x on one side, all the non-x's on the other side. Simples. Life is good, right? You don't need to do anything else. How about 5x equals 35? Now, obviously, we don't have a plus or minus sign in it, but we have a multiplication. We said the inverse operation of a multiplication is division. So we have division. I indicate that just simply by that. And we divide by the factor. Divided by 5. So we have 5x divided by 5 equals, and I need to buy the Xbox twice, 35 divided by 5. And what I see here is 5x divided by 5 gives me 1x equals 35 divided by 5, 7. And conventionally, we don't need to write the 1. We just simply write x. X equals 7. And again, we have exactly what we wanted to have. We have all the x on one side and all the non-x on the other side. It's a little bit like I'm talking about my relationships. All the x on one side, all the non-x on the other side. Mind boggles. We have 3x minus 7 equals 14. How are we going to deal with that guy? Because now we have a multiplication here and a subtraction here. And remember what I told you at the beginning? The one with the lowest hierarchy is addition and subtraction. So what we need to do is, let's get rid of the lowlife x. And I could tell you stories about that. Rather not. So, what do I need to do in order to get rid of the 7? I add 7. I notice that this is a minus. So I do the inverse mathematical operation. And I add 7 to both sides. And I'll get 3x minus 7 plus 7 equals 14 plus 7. And of course, you don't have to do that with different colors. I just do that here, to illustrate it. Minus 7 plus 7, what gives that? Of course, 0. So we have 3x minus 0 equals 14 plus 7 is 21. Are we done? Nah, we still have the 3 there. How do we get rid of the 3? We use the inverse mathematical operation to the multiplication. Divided by 3. And we get 3x divided by 3, oops, got the wrong color, equals 21 divided by 3. Three x divided by 3, that gives us 1x, equals 21 divided by 3, 7. So we have x equals 7. All the x's, one side, all the others, the non-x's, on the other side. Hey, cool. Life is good. Quick check. Is that right, what we have done? What we can do is we just simply put the x into our equation. So we said it is 3x minus 7 equals 14. It's always a good idea, especially when you're not totally sure, to put your result back in. So we have 3 times 7 minus 7. Careful, we have a hierarchy here. We have a multiplication. So we have 3 times 7. That gives us 21. Minus 7, that gives us 14. What do we have on the other side of the equation? We've got 14. If you are an accountant and you see that both sides of the book are the same, you are a very happy accountant because you don't have to massage the numbers and do creative bookkeeping. So in this case, we get the same result. We can be fairly confident that our x equals 7 that we got here is right. These are probably the most important calculations that you will come across, with the exception of the logarithms that we do next time. You find equation practice on my wonderful website. Let me see if I find that. I believe you've got the link to it. So there's some basic algebra, and there are some questions where you can practice rearranging equations, solve these equations, and also using the scientific notation in terms of exponents. Okay? I would suggest practice, because practice makes better. We don't want people to be perfect, but practice makes better. Okay? Happy with that? Have some lunch, and then I see you at 2.